Guys, let's see. Are there people here? I think that's the most empty chairs I ever spoke for. So who really wants to hear that? Would you guys mind to come a few rows more forward so I can see if you actually, when you start falling to sleep, then I know I do something wrong. But if you're all the way in the back, it's so hard. I really appreciate it. Okay, so the first 3 rows I will invite personally to beer. Cool. So I'm Stefan. Really appreciate you took time of the day to listen to stuff I will say. But I want to make this interactive. So if you guys having any questions, please ask me. I will try to repeat, or I will hopefully repeat the question and then try to answer that. So I want to talk about big data and flow theory. Who heard about flow theory? Let's see, hands up. Okay. Who heard about big data? All right, wrong conference. Okay, cool. So who I'm to talk about this? Well, if you wonder, this was kind of the first Hadoop summit. I organized that in a really, excuse my German, shady bar in San Francisco, and that's kind of some of the early nudge guys. So obviously, we always see the cutting up there. Michael Stack, HBase. Anybody using HBase? 1, 2, 3 people. Yay. Okay. I'm hiding in the back, and you guys saw, I think, in the last few days how big this became. Me and a few colleagues, we worked really early on this thing, what we call now Hadoop. Back then we called it Nudge, and now we call it Hadoop plus Spark plus Yarn plus Test plus whatever. And what I want to talk about today a little bit is how you can use this technology to optimize flow. What is flow, and how is it helpful? So usually flow is used heavily in online games or game industry in general. Who works in games? Nobody? Okay. Who works in financial services? 1, 2, 3. Who works, let's see, in retail? Nobody. Who works in technology? Okay, just check. I will build in some, are you guys still awake after lunch kind of things here? Okay, so the interesting thing about flow is that, yes, it's heavily used in the gaming industry, but it's also very, very interesting if you want to improve your application, might be online, offline, and let's really talk about how can you make your application more engaging. Again, what's the theory behind it, and how can we implement it with big data technology? So who I am to talk about this, beside that I wrote a little bit of code and painted a yellow elephant a little earlier. Well, so we work with a few gaming companies and a lot of financial services and retail companies, and we really help them to implement all of this stuff that I'm talking about. Check out what we do, Datamere. We have a little cool booth. We even 3D print your data if you're interested in that. But we basically an analytics application natively on top of Hadoop. So we have a little bit of experience about all this, what you can measure there. So I hope that's good enough. That said, I'm not a game designer. I really have kind of technology background in big data as I try to find out. What's the problem? Well, the problem is that it's not the goldfish, but it's actually that our attention span now in 2013 is shorter than the attention span of a goldfish. Studies show that the average attention span in North America for someone that has a job is 8 seconds. Goldfish, 9 seconds. What is interesting is that in 2000, it was actually 12 seconds. So it's getting worse, people. So I wonder what happens 2020. But the problem, really, I always joke, is that people today have ADDO, shiny. Right? The attention span is super short today. Actually, an information worker, quote unquote, is checking emails 30 times per hour. Who's checking emails 30 times an hour? Nobody? Few. And how can you really engage with users of your product that actually every 2 minutes look into a different software? How can you get them to the process of accomplishing anything in your game, in your product, maybe do a transaction in your online banking, what might ever be if they every 120 seconds in a different application, but every 9 seconds looking at a different spot in your application. What is really interesting, though, is that you have other engaging forms where people spend hours, right? It's not uncommon for quote-unquote hardcore gamers to spend 7 hours in front of a game. So what are those people doing different than that we maybe build enterprise software or consumer software, and we're really trying to keep those people involved into our product. What is really interesting there is that I think we really need to do something because the next generation has a problem in learning and in general efficiency as they work with our product. So this is really challenging. And most important, of course, for us as we're building products that hopefully make money is how do we get the eyeballs, keeping them involved, and eventually, obviously, that means money. How do I convert a freemium to a premium user? How do I get him from importing data all the way to maybe seeing some results, and so on and so on. So here's the concept of flow, right? This gentleman, he has a very nice name, Mihaly Csikszentmihalyi. Anybody wants to try his last name? Fantastic. You get an extra T-shirt and a beer from me. So he actually started after the Second World War trying to find out, after such a devastating event in a personal life, how are people getting over that? How can people become really happy? And a lot of research in the early 50s, 60s went into that, obviously, very early. Carl Jung, for example, people looked into this. And it very quickly turned out that actually money doesn't make happy. So just don't tell your boss that. Keep it to yourself. But with an increase of money, your happiness isn't increasing, and people really try to find out what is it that makes you happy in a day-to-day life. Obviously, if you're poor, if you can't afford food, you're very unhappy. But as you have a minimum social level, more money doesn't really help you. And Mihaly really dove into that. And there's a few really interesting observations. Number one, a human being can take 114 bits per second into the nervous system. That's the attention we have. Obviously, we have amazing compression algorithms. For example, I don't see every empty chair right now. I'm just blending that out, right? But I really recognize one empty chair and multiply it. But it's 114 bits per second. That's really small. And that's the limit of my attention. That's 61 kilobyte, not bit, but byte then per day. So maybe Bill Gates was right. We only need 64 kilobyte, never more. Who remember that? I saw one person laughing. Okay, you work in IT for a while. And over our lifespan, it's actually just 20 gigabytes, right? So we are definitely not big data. So, but looking into this, what is really fascinating is that what people actually perceive when they get happy is if they get in a flow stage that takes those 114 bits for one single task, and they're blending everything out. So this happens when we are in between a challenge and a reward cycle or skill improvement cycle. The way this actually looks like this is there's different areas here where if we feel too much of control of our job, we very quickly get bored, right? If it's a little bit of challenging, then that's cool, but you're pretty relaxed. If you feel too much in control, you very quickly, again, kind of want to do something new. But if you're too challenged, then you're getting nervous, right? And actually how our body reacts to this is increased heart rate, adrenaline, and all of this. But if you find the happy middle, we are actually in a flow stage. right? And flow is actually defined by we are completely involved. There's a sense of ecstasy, right? In Greek, ecstasy means out-of-body experience. And that really just means that the 114 bits per second that our nervous system can process are fully involved into the task we're doing. Is fully involved in playing the game or working with the software you design. We have a sense of inner clarity. It's very clear what we need to do as next step. We know we can get there. We feel it's under control. I talked about this a little bit. Sense of seniority and a sense of timelessness, right? So we really focused on that. We're using all our processing capabilities to do that. Intrinsic motivation. We really want to keep going. And I personally had that when I programmed software, open source software, for example. But when I programmed commercial software for some of the companies I've worked before, you know, sometimes I felt a little bored. Yeah, let me do this another join on Hive for you there. Or sometimes my bosses ask me for things that I just couldn't do. So if you really want to get in that stage that you're 100% engaged with the user, you need to get this kind of wave between, in a flow channel between the challenge and kind of the reward cycle, right? Replace skill with reward. You consistently do a step. Okay, this worked. It felt really good. Where's my next challenge? And obviously, what a lot of games do is they optimize for this. So the challenge, though, as you optimize for the game flow channel is everybody is different, right? So how do you really keep people in there? And the way a lot of applications or games doing this is kind of by processing to a number of words there or tasks that you go, and you constantly want to make sure that you understand where's the person, is he too challenged, you know, and the way to measure that is, for example, is he just staring at the screen? If you do eye tracking, is he figuring out what he has to do next? Or is he leaving your application? And in a perfect world, you can figure out, okay, for an average user, this is kind of the flow channel. And again, I will get we can get more technical how we all measure this. The interesting thing here is that this is your average user, and most companies really just do A/B testing to figure that out. The challenge, though, is every user is different, right? What maybe is very easy for me might be not as easy for my grandma. But what's really challenging for me might be super easy for a hardcore user of that product for a very long time. So how do you how do you design applications that just keep people consistently in that stage and really, you know, again, like not just optimize on the average, but also for the different kind of users that you have in the application. So what you actually can do is, it's called an iterative adjustment loop, where you basically consistently measure events and adjust your application to what you're observing. So in a case of a game, it's a player. You collect the player data, right? This is mostly event data. We'll talk about this a little bit more in a second. And you have a monitoring system that constantly really keeps in tap on the user and see where's he, how's he doing, how is he progressing, how is he moving forward. Usually you have system data as well. This is really information about your application and which state, if you have a stateful system, is he interacting with other users there? And you need to push all this data, obviously, into an analytical system and then really understand, okay, where's the state of my user, where's the state of the system, and how are they getting together? And with this analytical results, that could be recommendations, for example, for your engine. You do certain improvements, adjustments to your game system, where you improve the experience of a game. So a few examples of this, for example, do you guys know, the company in Cupertino called Apple? Who knows this company? I know this, okay. Who does not know Apple? Okay, everybody in between still sleeps. So they have a whole bunch of cool software that actually really adjusts based on your user behavior, and we never really figured that out. Right, so one of their enterprise products is Logic Pro. And in Logic Pro, you can really switch to a dumbed down version or to a super advanced version that gives you a trillion more functionality. And what they really figured out is how to observe when people getting to the stage that you're done with the basic functionality and when it makes sense to iteratively expose the user to more functionality. And again, this is improving overall the happiness of the user and the engagement of the overall product. So let's get a little bit more technical. How would do all of this in your application? And I talked to a few folks in the last couple of days. It really depends on how complex your system is, but if you're designing a new system, I would highly recommend to just log every single event you can do as a JSON log file. Anybody knows why we want to use JSON and not XML? Well, XML just blows up your data, right? So if you don't really need to use blown up formats like XML, don't do it. I mean, yeah, there's binary XML, but JSON is really a great log file format. That said, though, I had a long conversation with a company. They had something like 17 production systems, of course, 16 of them running with Apache log files, and they made a big effort to move them all into JSON. That doesn't make sense. Just leave it as is, because one of the really cool things is as you aggregate all the data into a Hadoop system, you aggregate it as is. Right? So I think one thing that we always forget, Hadoop is a virtualization platform. Hadoop is a platform that virtualized storage and compute and basically makes it so incredible cheap that adding more hardware is significantly cheaper than the lost opportunity on innovation that you have as you may be building a Hive schema or kind of trying to do the same thing as you tried in Oracle with Hadoop. When we built Hadoop many years ago, the idea really was, we don't know yet what kind of analytics we want to do, and we certainly don't want to do the same old database technology. So the idea was, we build a system that's highly efficient to get any kind of data in, and then really, almost like 3D printing, get the data out as you want to. Right? So if you guys are trying to normalize all your log files or think about how you maybe structure your data, it doesn't make sense to structure the data in the moment you write it to Hadoop. You want to structure the data the moment you do the analytics and pull it out. That's really the big idea of Hadoop and the notion. It got a little lost in the last few years because I think we all know from an IT perspective, and I'm an IT guy myself, we really like SQL. We're lazy. We learned SQL. Why should we learn MapReduce? Why should we learn something like cascading that supports schema on read or use other products? I know SQL, but you're really losing an opportunity here. Right? Again, the idea of Hadoop is a schema on read that allows you to aggregate all of your log files and then, quote unquote, on demand you do this. Another big topic really is how do you aggregate data for such a system? Many times I have conversations about push versus pull. So there are systems that support push aggregation. That would be, for example, Flume. Or there are systems that support pull data aggregation. Well, the problem with a push data aggregation system, especially if you do analytics, it's just not worth it. So we have one of the gaming companies, they now have something like 3,500 servers. If you run 3,500 servers, installing additional services on each of the servers, like a Flume, for example, or pick your other favorite push data aggregation system, like a Splunk agent or something like that, it really costs you a lot of money because you're investing a lot of resources there. And guess what? If you want to have data delivery guarantees with a push system, it's getting really complicated because you actually have to buffer the data, then send it over zip, then you have to do a handshake on the MD5. Did I really get the data that this guy wanted? It's really, really complicated. I definitely would recommend to look into a pull mechanism. Because in the end, the latency for pull versus push is still the same thing. And if you really think about those folks that optimize data, transport systems, if you think about Mural or, back then we called it JMS. Who remembers JMS? 1, 2, 3, yeah, okay. It's the same guys that laughed when I said 64 kilobyte, right? So a publish-subscribe mechanism is just the best and the fastest, most reliable way to transport data. And one thing that is super cool with Hadoop is you can basically use Hadoop to do a pull aggregation. So you would write an import format and use just SCP, for example. There's a beautiful little open source library that supports SCP. And what you can do now is with low-level low-level Unix or Windows services that are most likely installed on any server anyhow, that don't take a lot of CPU power, you can just every 5 minutes copy log files. So sometimes I see a lot of companies that we work with trying to over-architect things. Holy moly, how do we do the data aggregation? Let's install a Java VM on 3,000 servers. A third of the CPU is going just for this agent off, and 2/3 running something else. It just doesn't make sense. If you have SCP installed on your system and you have latencies that are okay with like a couple minutes, just every couple minutes do an SCP, and that SCP again can be run as an import job for Hadoop. So it's super simple, beautiful, and it scales tremendously. So consider pull versus push data aggregation. So this one use case that we built it, or that this really big game company built it that we're working with, and by the way, just to give you an idea, this iterative adjustment, they really mastered that. They're running 3,000 jobs every single day to analyze the data, and based on that, consistently looking where are the people, what are they doing, how can we optimize. What they basically did, instead of trying to find the perfect schema, trying to find the perfect log format, they basically just created a little JSON log format, and every software developer that works on the game can just log into a file. And then, as mentioned, with an SCP job, every few minutes they pull the data in, and then again, as a view on the data, they go to the raw data and filter really by event. And the event could be the user logged in a specific game, the user had a challenge and the user was successful to see the challenge, or the user converted from a freemium to premium, he bought a shield or he bought some crops, whatever it might be. Again, if it's your enterprise application, you can really see, did he fill out the form, and so on and so on. And there's even really cool JavaScript libraries now that allows you not just to collect the data per every HTTP request, but actually per every mouse click. And you can log that to the backend. And obviously, here's where the data really becomes big. Right? This is really here where it makes sense to use Hadoop. You pull all this data in, and then you can filter everything by event, and you can look for virality. Right? If you are LinkedIn or Facebook or Twitter, what you want to look is, did the user engage with other people? Did he invited more folks? You can look for monetization. What made the user get to a certain point that he upgraded from freemium to premium? What did the user do to actually encourage someone else to upgrade? And you certainly can measure engagement, and this is where we're coming back to the flow, where we keep people longer involved with our product. We're kind of the digital truck dealers, so to say. The way we measure this, obviously, again, is a challenge reward. And what I mean with reward is, did the person achieve that challenge? Did he overcome this? And we want to measure that over time, again, as the user's getting more skilled in our product, in our game, in our online application, as he knows how to get through this. Is he really engaged here? And there's a few cool things that you can do, and this is just a screenshot out of our product in a specific game here, but you can compare and put users then in buckets. Right? And the reason you want to do this is because you want to, again, kind of look into your product and really trying to understand on which levels, what kind of skill levels do you have, and are there buckets, and can you optimize your product for kind of the hardcore users that use your online banking on a daily basis, or your shopping for that matter, or are they new? And how do you guide someone to an e-commerce application that is there the really first time? Do I send them signals? Maybe not the paperclip as Microsoft, but maybe in that direction. So what is really cool is making k-means happening on Hadoop. It's actually not as difficult. There are tools like Mahout, you guys heard about that maybe. Datamir can do this, but you also can just write it yourself. K-means is really one of the easier to implement data mining algorithms in MapReduce if you want to go that far. The next step really would be then kind of a decision tree. Right? This is a little bit more difficult. This happened to be a random forest and just a screenshot from a customer here. But with a random forest, you can clearly understand as of per skill level, how are people moving to your application. The interesting thing with random forest is the way you want to do this is actually on a reduced task, and then you want to consistently iterate on the reduced task to compact your tree. So the way this would work if you want to implement it yourself is basically really, in a mapping stage, you filter the events you're interested in and prepare them so they're grouped on a per session basis. And then you basically build kind of the session per user in the reduced stage, but consistently laying the decision tree or the path of every user over each other. And then on a regular basis, you want to prune the tree, right? You just want to say, you know what? Only one person went that direction, so let me cut this off so that your decision tree, your basically chain of events, is kind of keeping compact. So also rather easy to implement with a MapReduce environment or test for that matter. So what are the results, right? If you have all this information, what's really interesting here is that you can adjust the challenge. You can adjust the challenge in your product. You can, for example, in a game, you can, put stronger competitors or bigger challenges to the user. But it also means if you're doing an enterprise application, you can expose the user to more, sophisticated functionality, right? You want to have a very low challenge in the beginning. And this is how we, for example, in our product doing this, we're consistently looking how people coming to our product. And we realized, for example, it's really challenging to get certain functionality done in the beginning, but people need to get over there. Well, we took this task out and kind of just said, here's some sample data, or here's how you're getting through this. And when the user then kind of acquired that knowledge, now we allow you to load CSV data. Oh, you know how that goes? Okay, now you can connect to a database. So you can dynamically adjust really the functionality of your product and overall get a more happier and more engaged customer. What I found fascinating in one of the gaming companies we're working with, though, is what they do, they adjust the gamer mix. So in especially massive multiplayer games, what is really challenging, obviously, is competing against the other folks in the game. And it's what companies today do is fascinating. They're recording a gamer and then play back that behavior later to another gamer. And if you obviously can measure all the engagement and kind of the skill set of those gamers, you can really then change the mix of folks you're playing against, right? So the first step really would be I play against a not a skilled gamer. Oh, I got this done in a minute. Okay, let's go 2 levels up. Oh, it took longer. You didn't win against him. Well, if you not win in the next task against someone, most likely you will leave the game because I can measure that if you more than twice lose in one session. So why don't I just play back a less skilled gamer to you? It looks like it's real time, but it's just played back and I adjusted it based on the result. And the big beauty here is really that you get highly engaged users of your product or of your game. In the end, of course, that results into more conversion. So I promised the AV guys I will make it in time. This is really my last slide, but I want to open it to a little bit more technical conversation if you guys want to go into that around data aggregation and implementing all the details. Just really wanted to give you kind of the framework here and see if you guys have questions in that area. Let's see if I can see all of you guys. There's a question. How did I get to the 114 bits? I read a research paper that said that. Yeah. So, okay, actually, let me repeat the question. I'm sorry. So how did I came to the 114 bits, and how did they get there? So it's it's really interesting from that perspective. Actually, I was personally involved in a study where I got one of the space helmets on, and then they measured my brain waves. So it was really fascinating. But so the retina obviously has a much higher bit rate that goes into our brain. But what really then gets into our short and long-term memory storage system is filtered. Right? And this is really fascinating. There's also this interesting book called Thinking Fast and Slow. Maybe you heard about that. So our brain almost works like a buffer system. We have an in-memory system that right now is active for me, and tonight I will process all this. And tonight my brain will actually, again, apply a compression algorithm and really remember you, for example, because I interacted with you, but not remember the empty chair over there or the light over there because it wasn't really meaningful. And in that context, really, the compression that goes from your retina and audiovisual system overall, then into your nervous system that you engage is significantly smaller. And the way they, at least when I was involved, measured that is really what triggered and in which frequency my nervous system by showing me a bunch of pictures and interacting with those pictures. So they basically said, okay, we send you, that many pictures per second, and then some pictures I had to pick out like differences, actually engage my nervous system. Like, press a button when it's a female versus a male kind of thing. And in that moment, they basically measured when did your brain waves engage. Didn't answer your question really, but I think it's really fascinating, right? So one observation in big data is that everybody is trying to analyze more data, what totally makes sense, but the results we're getting, the insights, still need to be very highly compressed. Right, so it's almost kind of a funnel as we're analyzing data. And currently, especially Hadoop doesn't really respond to that very well. Hadoop is kind of a freight train. It's perfectly to move ginormous amounts of data. But guess what? After I set a filter for a certain event, it's very small data. So we're usually compressing data very, very quickly that can run in memory, but we still run it as MapReduce. On the other hand side, if you just go memory, then you can't really find all the events if you sample too early. Anyhow, more questions. I know you have a million questions. You're just afraid to ask them.
I see how you can measure flow looking at a gaming system. How do you do that for a business application?
Yeah. So the question is, how do you measure flow for a business application versus a game? So the companies that got really good in this is LinkedIn and Facebook, right? So what they really did is looking at the engagement over time. And you maybe saw that at some points, LinkedIn or Facebook is coming back and saying, why don't you set up your security settings? But they certainly don't ask you to do that the very first time because as you get exposed to the application, it's actually really challenging to set up Facebook security, maybe by design, I'm not sure. But so what you really can do in enterprise application is to understand as someone comes in, and you really closely need to work with UI designers and product managers, certainly. As someone comes in, how do you really get him very quickly into that challenge and kind of skill improvement loop, right? So the person sees your application the very first time, and his task might be, maybe it's an e-commerce application, or I actually talked with a trading company that do online trading, how they can improve flow. And what you want them to get very quickly is to kind of trace a bullet. If their task is, I want to buy something or I want to trade something, get them very quickly to be able to trade, to make one trade. And for example, what we saw with a few companies is that they give you a first few trade to really encourage you to trace the bullet first. So with that, you have an encouragement to really make it to the challenge and get a reward because you had the first free trade and you learned in the process. And in the first few trade, quote unquote, you really get a very simplified user interface, less functionality. Where in the very next trade, you have more functionality. You can do it based on time, based on currency, or based on thresholds, and so on. You have more functionality. And that's how you can encourage or change your user application. Again, it's an overall more complicated system by driving user experience, data-driven user experience. So you definitely need to commit as a company. But the companies we work for that implemented that see a tremendous increase in engagement with their product. And if you're a trading company, you want people to get hooked on trading all the time, and you would want to get them very quickly to the point that they feel very comfortable in the system, if that makes sense. So sometimes it's very easy. You basically, so I saw one application basically having a Spring configuration file that switches on functionality. And then they clustered user behavior, and they said, okay, well, these are our newbies that are kind of newbies +1. These are our mediocre, kind of okay users, and these are our hardcore users. And based on observed and measured engagement in the product, they basically just show you different, expose you to different things. And they're actually not really switching things off, I have to correct myself, but they just like not make it as prominent in the user interface, if that makes sense. Okay, I think I have one more question. Let's see. All the questions in the back? No? All right, well, thank you very much for spending some time with me. Come by and check out what we do. It's really fun, very visual. And please, next time, consider how you want to build your big data analytics system, and maybe think if you can improve your overall application based on data from the user behavior. Thank you.